Hi, everyone. Thank you for being here again for the next installment of our NEMO Stormwater Seminar Series. I am pleased to welcome back Dr. Steve Souza, owner of Clean Waters Consulting. So take it away, Steve.
Hey, Avery, thanks for having me today. And again, thanks to all of you for tuning in. We're going to be talking about manufactured treatment devices, MTDs. I think a lot of you have heard about MTDs, but we're going to be looking at the application of MTDs as a means of managing stormwater from urban sites, areas that have been developed. They've been developed for a while. There's not a lot of opportunity within those areas because of the degree of development to actually go in and do some conventional green infrastructure type of stormwater management. So there's definitely challenges to retrofitting urban and suburban stormwater systems. And a lot of this has to do with the lack of space. We don't have a lot of room to go in and construct brand new surface type green infrastructure best management practices. So bioretention basins, bioinfiltration systems, even bioretention and bioinfiltration swales and conveyance structures. In addition to that, when you have a lot of impervious cover, what ends up happening is our flows are very flashy, meaning every time it rains, you're generating a lot of runoff, and that runoff ends up getting generated very, very quickly. What makes it very difficult also when you're dealing with vegetated type of green infrastructure best management practices is that inconsistency of flow. You only end up with inflow during or shortly after a storm event. Between storms, things can get pretty dry, and that can create stresses for plants if you don't use the correct type of plants. Then on top of that, with urban and even suburban type of settings, we end up with a lot more litter and trash that ends up getting washed in with stormwater runoff. There's a greater amount of sediment from materials that are placed on roadways for, like, say, during the winter to prevent ice and snow buildup, or even because of the fact that there's not a lot of green areas, you end up with a lot of sediment in the way of fine sands and silts that accumulate on top of parking lots and roadways that get washed in to our receiving systems with storm events. And then the other thing is that really makes stormwater management difficult in urban setting is a lot of times you need specialized equipment and there's specialized maintenance needs. So that means our staff needs to be trained properly in terms of how to deal with managing or maintaining rather those best management practices that are being put in to protect the bay. And this is where manufactured treatment devices come into play. These can be considered sort of a green-gray stormwater solution. They are recognized by DEP as part of our green infrastructure approach, but in most ways, they actually replicate a lot of the conventional gray stormwater management solutions that are already in place. The big thing about MTDs, or manufactured treatment devices, is that the majority of them are subsurface. So now you can get away from the problems associated with not having a lot of land mass available for constructing new structures. They are scalable, meaning that I can use them on very small applications, maybe even for like a driveway. I'll show you some examples where they could be used for an individual parking lot, or they can be used in series to maybe manage runoff from a larger drainage area. Often there's no need to make any major changes to the existing stormwater collection system, so you don't have to alter the pipe network, which is a big cost saving. As I mentioned, they are accepted by DEP within a given set of parameters as an acceptable way of managing stormwater runoff. They do a really good job in mitigating peak flow, which means they can decrease erosion problems downstream and even some flooding problems downstream. But they don't do a good job in terms of recharge because essentially these are concrete boxes that are placed below the ground. And their pollutant removal efficiency is pretty good with respect to particulate pollutants. That includes total suspended solids, where they can remove anywhere from 50 to 80% of the solids that are associated with runoff. And with that, any of the other contaminants that are adhered or adsorbed to those sediments. But they don't do a really good job in removing dissolved nutrients and dissolved pollutants. And that's because there's no plant component to these systems. As I mentioned, they are accepted by DEP as a stormwater management solution, even for major development, for new development. And if you want to get into more of the details on that, you can just go into the stormwater regulations, NJC 7:8. But they need to be verified by New Jersey CAT, and they also need to be certified by New Jersey DEP, be used as part of satisfying stormwater requirements for new development. They can also be utilized as a means of managing stormwater for projects that are receiving funding from the New Jersey Environmental Infrastructure Financing Program. Again, they need to be CAT certified, verified rather, and DEP certified, or they have to be installed in keeping with the finance program policy. And then finally, an MTD that's not CAT verified or DEP certified can be used, but only if it's not intended to satisfy those requirements of the stormwater regulations, or they're not being subject to the funding requirements of the funding policy of the financing program. So there's a whole list of MTDs that are out there that are certified for use, and you can go to this link to learn more about each one of those. But as you'll see, they take a lot of shapes and sizes, and they do have their application in managing stormwater runoff to Barnegat Bay. So DEP's take on MTDs as a green infrastructure option is that for an MTD to be considered by DEP as a green infrastructure technique, it needs to meet the definition of green infrastructure as in the rules. So that's NJC 7:8, subsection 1.2. And specifically what that says is that the MTD shall, 1, infiltrate into the subsoils. And as I mentioned, not a lot of these do. Or 2, treat stormwater runoff through filtration by vegetation or soil. And we'll show some examples of techniques that do that. But unfortunately, a lot of them don't. And so they're not really considered true green infrastructure, but they can be a supplement to green infrastructure options. So use in Barnegat Bay, I think there's a lot of applications because we have a lot of lands that have been developed well before New Jersey had any stormwater regulations in place. So that's well before 1985. And as I mentioned before, they're a great option for retrofit and redevelopment types of projects. And they can also be utilized as a pre-treatment type of technique in combination with other green infrastructure stormwater management applications. So as I mentioned, there's a whole host of different types of manufactured treatment devices out there. And we'll look at some applications of differing size and differing capabilities. So some of these going from small to large, with and without plants. We'll look at basin inserts and filter bags. These would be the most simple, but they have their limitations. Tree boxes and planter boxes, which are becoming more commonly implemented, not only in terms of retrofit applications, but new development. And then some of these larger chambered baffle boxes or large chamber boxes that include these swirl condensers that work sort of like a big, let's call it sort of like a dynamic system that causes material to settle out within those chambers. And then there's some other ones that I won't get into today that actually use some type of filtration or cartridge system. Those are very expensive and they're not that popular simply because the replacement of those filters takes specialized equipment, and each one of those filters or cartridges can be very expensive. So there's ways to use MTDs that don't necessarily you need to use these filter cartridges to achieve those benefits. So let's look at like one of the most simplest techniques, and I've used these in a lot of applications. They're being used statewide. And these are these simple little catch basin inserts. This is just one example manufactured by FlexStorm. And essentially that filter would sit inside of a conventional catch basin. And its function is really to remove sediment, leaf litter, other types of trash, particulate removal. And the way these things are designed is that they basically treat the runoff that's generated by that 1 year event. So that's about 2.75 inches over 24 hours. A storm of that magnitude has a 100% chance of occurring every year. And then smaller storms, as well as the first flush of storms that are in excess of the 1 year storm, the larger events. Anything in excess of that 1 year event would be bypassed through the filter or around the filter, preventing the resuspension of the material that has been captured within the filter. The really cool thing about this is that those steel frames can be custom designed and fit into any type of conventional basin. So in some of the older developments where maybe there's an irregular type of catch basin used throughout the entire development, these work really well, and I have used those in these applications. The downside is really that they have very small capacity, only about 5 to 6 cubic feet. So maybe about what you would put into a standard wheelbarrow. So that means they need to be inspected and cleaned out on a pretty regular basis. So this is an example of a catch basin that's being modified with one of these filter bag inserts. And you can see here essentially what the public work personnel are doing is clearing all the material that had accumulated at the bottom of that catch basin. Once that's removed, they insert the filter frame in the bag. And then subsequently, they come out, inspect. In this application, they're being inspected once every 3 months. And then determination based on visual inspection as to whether they need to be cleaned out. They can be extracted in total as being done on the left side, the grate, the frame, the bag, and then dumped into the back of a dump truck. Or what's easier is to come in with a vac-all and basically just suck out all of the material that has been collected by the filter bag and then proceed to the next one. That's a lot quicker and easier way to clean these out without destroying bags or adding to the amount of labor associated with the cleanup process. So that's an example of a small scale MTD. We can then ramp up to some larger scale applications, and these will be the tree boxes, the planter boxes, tree trenches that I think a lot of you have become increasingly familiar with. And essentially, these use a combination of a special type of soil mix along with plants to filter, assimilate, and remove pollutants, including dissolved pollutants from stormwater runoff. And some of these can be designed with an underdrain or perforated bottom so that you can actually promote some degree of recharge as well. Here's an example of a tree trench that's been placed in the middle of a roadway median. You could do the same thing in the middle of a parking lot. And essentially you can see here, we've taken up no additional space. This was just macadam before, and this has been replaced with some type of functioning stormwater management system. Planter boxes work in the same way. These tend to be a little bit more custom designed. They're concrete boxes, so think of them sort of like a big planter that you would set into the ground. Again, all of these devices, all these manufactured treatment devices are designed to work primarily with those commonly occurring storm events, the 1 year and smaller, or the first flush of the bigger events. The key thing here, as is the case with the plant box, these planter boxes, as well as those filter trenches, is that we're using a combination of a specialized bioretention soil mix with a variety of plants. So it's the plants, the soils, and the ability to hold that water for a given amount of time that increases the amount of pollutant removal. So I'm going to show you an example of a project that was done at Toms River High School North. This was with 319H grant money administered through New Jersey DEP. The project lead on this was the American Littoral Society. And essentially, we had an opportunity here at the entrance to the gym to implement and install a couple of tree boxes. So you can see these boxes can be fairly large. This one's roughly about 30 by 20. And starts off by excavating a pit down to the bottom. A lot of those pipes that you see there are all the existing infrastructure that needs to all be accounted for during the design, construction, and installation process. But essentially what's being created here is a custom concrete box with an underdrain. So this does have the ability to allow some of that collected runoff to drain back down into the subsoils. This is the process. Again, you get a sense of how big this is by just the scale of that individual standing in the bottom of the box, with relative to the top of the box. And this is all filled in with a specialized bioretention soil, high sand content, about 90% sand, and around 20%, 15 to 20% organic material by weight. Getting close to getting ready to plant the boxes. And here you can just see all that was done is that these simple little curb cuts were created so that as water flows down through this, primary access to Toms River High School North, stormwater can discharge into the planter box and be treated. And this is what the planter box looked like about a year following completion. So on a rainy day, stormwater comes down the road, enters via this curb cut into the basin, and then is treated by the combination of soils and vegetation to reduce pollutant load, as well as put some of that runoff back down into the ground. Tree boxes, similar type of concept. However, most tree boxes, they come from a variety of different manufacturers. They come in a pre-designed size. They do work again either with, similar to that Toms River example, where you can do curb cuts, or you can actually route flow directly into the tree box. Here's an example of a project that I worked on at Ocean County Park in Lakewood, where we installed a couple of tree boxes in one of the parking lots that service what's called Swimming Lake at Ocean County Park. And here, there's the boxes after they've been installed. Prior to this, all of this runoff would discharge to this catch basin that then would just discharge into the lake without any treatment. Now, the first flush, well, the storms up to the 1 year and the first flush of larger events enters the tree box, where it's being treated by a combination of vegetation and, again, that biotreatment soil. This is the second box. So this is the first one that I showed you. Here's the second one. Again, any overflow goes into that catch basin, but this is designed, again, to collect all of the runoff from the 1 year event and smaller storms. So remember, that's 2.75 inches of rainfall, and anything less than that gets routed and completely managed by this tree box. Anything in excess of that, it would collect that first flush, and then the overflow is managed by that catch basin. So no alteration here of the existing pipe work. This is just being put adjacent to and working with the existing pipe network. So I'll give you another example. This is, again, an extension of that project that was done by American Littoral Society, where we installed a fairly large Filterra tree box, about 91 square feet, in one of the parking lots. And all this was done here was to modify the curb line to allow water to enter the box as opposed to just flowing into a large catch basin. And then these were planted, as was the case with the Ocean County Park example, with serviceberry. So this is the project after completion. You can see here, this curb used to just run directly along here. All of this runoff would just cascade down off the parking lot and into a catch basin and then into one of the headwater streams to Barnegat Bay. Here we have our box in place with the service berries planted. Again, this is filled with that bioretention soil, and essentially runoff hits the parking lot, is channeled into this for treatment. These can be used, as I have done in other applications, where even like in the middle of an existing parking lot, without making any alterations to the pipe network, these can be set in place. In this particular application, there were 4 of these put into service. And then we can move from these planter boxes to these larger manufactured treatment devices. So as I mentioned previously at the beginning, these devices essentially use baffles or some type of means to slow water down to allow sediment particles, trash, debris to collect within a containment area. And then the water is passed out to an existing pipe system. So again, these can be used in retrofit type applications. There are a variety of different manufacturers. These are just 2 of them, Contact and AquaShield. I'm going to show you again some examples. This again is an extension of what was done at Toms River High School North, again through American Littoral Society. This is a pretty large unit. You can see this going into place. And essentially water comes in through the existing pipe network into this chamber. This chamber is about 8 feet deep or so. This is the flow path. There's a series of baffles that help separate out of that flow path, number one, by slowing it down, particulate material and trash. This helical swirl condenser, then as water enters, it dissipates energy and causes more sediment and particulate material to settle out before the water then exits the basin into the existing pipe network. Again, just to give you a sense of the scale of this project, this is one of probably the largest MTDs that you would be working with. This is a pretty large structure, and it is managing a fairly large amount of drainage area, probably on the order of around 8 acres of impervious cover. These are some other installations that have been done through the Deal Lake Commission at Asbury Park in the middle of existing roadways or at the terminus of existing roadways. And again, because of the limited amount of available space, these MTDs are part of the stormwater management solution that are being used to decrease pollutant loading to Deal Lake. They are inspected on a quarterly basis, and typically, depending on the amount of flow and the amount of material, and you can see here, there's a lot of floatables that they collect, cleaned out either on a quarterly basis or maybe once every couple of years, twice per year rather. This is one of the initial units that were installed. This was installed around 2011 or so. Again, this represents about 6 months of accumulation. This is another one of those helical swirl condensers, and this was put at the end of Comstock Avenue, right next to Asbury Park High School. Some smaller installations around Deal Lake. This is the much smaller box. You can see this is probably only about 15 feet in length, but again, another one of these helical swirl condensers. Water enters in this direction through the 2 initial baffles, and then additional treatment. And this is really only after one of the first storms, we went back, popped the lids to inspect how this was working, and found even after just the first event, we were doing a pretty good job in terms of removing oils as well as trapped debris. This is just another example. This is one produced by Suntree. This would do a pretty good job of removing a lot of leaf litter. It doesn't use a helical swirl condenser, but again, this is sort of like a filtration system that uses also baffle boxes. But as water enters, it passes through these screens. Debris is trapped on the top of those screens. And then through conventional manholes or some type of grate, these can be accessed for inspection and clean out on a quarterly basis or maybe twice a year. This particular unit was able to, it was documented as removing, it's a project that I worked on, about 8 tons of sediment within 4 months. So that's pretty astounding. So in summary, although MTDs are not true green infrastructure stormwater management solutions, they do a better job than conventional gray stormwater management techniques in terms of removing pollutants, particularly particulate pollutants. But they're especially well suited for retrofit applications and use in urban and suburban areas. And this is because they don't require a lot of above ground land for their installation. They can be installed without any major alterations to the existing pipe network or stormwater infrastructure. And as I said, they're really good in terms of removing particulate pollutants, floatables, and sediment. They do require frequent inspection and maintenance, whether we're talking about the small filter bags or the larger manufactured treatment devices. And that does require, in some cases, some type of specialized equipment and personnel that are trained with that. But, as I said before, in a lot of these situations, this is better than what is there now and does provide a means by which to decrease pollutant loading to Barnegat Bay. Some of these, as I mentioned, with the filter bags, they can only manage a small amount of runoff or a limited catchment areas, but some of the larger ones can do a pretty good job in even managing a large expanse of impervious surface. One really cool thing about them is that they can be linked with other green infrastructure management techniques. So they can be used as pre-treatment to increase pollutant removal. So think of it as a means of screening out all of the grosser larger contaminants and leaf litter as well as floatables, and then routing that pre-treated water into perhaps some type of bioretention area. And that's done quite frequently in a lot of urban settings. There's a lot of examples of applications of MTDs being used in combination with bioretention that have been put into place in Philadelphia, New York, even Newark and Camden. So with that, I thank you. And Avery, again, thanks for having me. And hopefully everybody's learned a little bit more about manufactured treatment devices and the role that they play in managing stormwater runoff to Barnegat Bay.
Thank you so much, Steve. I hope this presentation is valuable to our more technical audience. For those who might just be tuning into this presentation, we have a wider range of different audience targets. So if you're a homeowner, if you're a stormwater operator, if you're a municipal employee, we have lots of information for you. So hopefully this helps break all of that down into practical stormwater management. Thank you very much, Steve.